In this spreadsheet, we're going to show how a student could figure out the energy change in a chemical reaction. So if you look at the spreadsheet from just face value, you see numbers. If you view it from the show formulas thing, you'll see that behind this are a variety of different calculations. For example, if I click on I7, it says take the value of G7 and multiply it times H7. So I have to find out what G7 is, which happens to be the number of bonds, and I multiply it times the energy per bonds, which makes sense that we're trying to total up, in this particular case, the number of the energy for all the interatomic bonds that are broken and those that are formed. Again, if I click over on this column here, you can see the same type of thing. Finally, when you go over and you look at the actual calculations, you can see that it says, okay, take D28 or I28 or whatever, and we can go down here and we can see that these ones are based on the summation of a column. So for example, this one right here is based on the sum of D7 to 26. So it's that column right there. So let's go ahead and just change the view back to normal view. And let's look at a sample here. Here's a sample for the combustion of methane. So just the natural gas you'd find like in most stovetops. So you have methane, which is combines with oxygen, and it produces a lot of heat, obviously why we cook with it. And then carbon dioxide and water vapor are the products. And so student might look at this and say, well, I see that there are 4 bonds in methane, so I have to find a carbon-hydrogen bond, which I'm just going to turn that 4. And now in terms of oxygen, that we have 2 oxygen molecules, or double bonds, so 2 of those are broken. So we look at this and we say that it took 2,620 kilojoules per mole to be able to break those bonds. And now we're going to look at the ones that are formed. So the ones that are formed, as we see, well, there's 2 carbon-oxygen double bonds. So we'll put that there. And then we can look at water, and we can see that water has 2 hydrogen-oxygen bonds, but there's 2 molecules. So we have to find hydrogen-oxygen right here. So we'll find the hydrogen-oxygen bonds. We're going to look for. So we put that in, and then we can look over here and we can calculate. We can say, okay, it took 2,620 kilojoules in, 3,466 came out. So there's an energy change of minus 846, which means that energy was given off. It was an exothermic reaction. So the point of this is not so much the chemistry, but understanding how the spreadsheets work and how you can use them in a very specific curricular application like this right here.